So now things get really interesting because, well, maybe I should follow the order of these slides instead of getting ahead of myself. I'm now going to start an application that needs two containers talking to each other. The first one is a web server, and that one will be exposed to the outside world. And the other one is a data store, and I'm using Redis because it's the simplest data store ever. That's a little trick, like when you want to do demos and you want the demos to be as simple as possible. If you use a SQL server, you will typically have to create tables, etc. What is nice with Redis is that, for instance, in the demo that I have a counter. I don't even need to initialize the counter, because in Redis, if you say increment counter XYZ and the counter XYZ does not exist, it will be created with an initial value of 0 and it will just work. So I love Redis for these reasons, and also plenty of other reasons. But so I'm going to put those two containers, like the web front end and the Redis store, on that Unicorn network. The application that we are going to use, yes?
This, I was just wondering, does it work across hosts?
Does this work across hosts? Yes, if we enable swarm mode, basically.
Okay.
So out of the box, like if it's like 50 something of us here, so we have like 50 Docker machines, and so out of the box, if you create a container on a private network and try to communicate with somebody else, that doesn't work. But if somebody creates a swarm by doing Docker swarm join, Docker swarm init, and everybody else does Docker swarm join, then the networks are going to be able to ping each other. So I'm going to run the web front end. That web front end is using a public image on the Docker Hub called Training Wheels. So my command is docker run dash net unicorn dash uppercase P dash D. Am I forgetting stuff? Nope. jpetazzo / training wheels. And as you will realize in less than a minute, this is an extremely complex application. Okay, it's now up and running, and so I really wonder what it could be, so I'm going to check with Docker PS. Well, I'm starting to have a bunch of things that are kind of making our lives difficult here, so I'm going to make some cleanup. I'm going to do Docker RM on like a cranky Hamilton. Well, that was not the one I was expecting. That's an interesting completion, sir. Okay, Docker RM C47. So when you try to Docker RM, so to destroy a container that is running, it's going to tell you, nope, stop the container before attempting removal, or force remove. So you can do Docker RM-F, and then it's going to kill and remove the container. So I'm going to Docker RM-F, a few of these containers. Okay, yeah, now I can see my Training Wheels containers. So it's been running for about a minute, and it's telling me that it has something on port 5000, and it's been mapped to port 32769. And we can see that it's running Gunicorn, and it's a coincidence if it's running Gunicorn and I'm running it on the Unicorn network. Gunicorn is just a Python application server. So let's see what we have on port 32769. So I go to the IP address of my VM on 32769, and I have a big error page. And if I look into that error page, okay, if I zoom a little bit, I can see that the error seems to be connecting to Redis 6379, name or service not known. So basically, it was not able to resolve the name Redis. So without knowing really what this application is doing, I'm going to try to give it what it's asking for. I'm going to create a Redis container in the same network with the Redis name. And to do that, I'm going to do so docker run --net unicorn -d --name Redis and use the image Redis. It's going to pull the Redis image. Now it started, and now I'm going to just reload that page, and now I don't get an error anymore. This is telling me the request was served by container ID blah blah blah, and this container served that many requests so far. If you're wondering what this application is, once you have multiple front ends, each time you hit a front end, it's going to increment its own counter. So you can use that, for instance, to test load balancing. You can put, let's say, 4 front ends, and then you put a load balancer, and then you send traffic to the load balancer, and normally you will see all the front ends show up there. So that's how we did service discovery. And if we wonder, okay, what did the code look like? I'm going to the repository on GitHub that has the code for training wheels. Wow, that person is crazy. They are using emojis in their commit messages. So if I go to counter.py, I see this is how I connect to Redis. I do Redis SQL Redis. That's a lot of Redis on a single line. But what's really interesting is that one Redis here. I don't really need Google Translate to translate Redis, but whatever. Here in classic code, I would have put like the IP address or the name of my Redis server, maybe 192.168.1.3 or redis.superawesemehostedredis.io, etc. But here I just put Redis, and I rely on the container engine to associate the name Redis with the IP address of the Redis container, and that just works. The nice thing with that is that if I want, I can have multiple containers with the same name but on different networks. So if I'm using --name, I have to use something else. I have to use something else than --name for that to happen. And let's make sure that it's really what I want to show. Yes, scope. So I'm going to show that with my Elasticsearch thing. I'm going to create another network. So docker run --net rainbow. Well, I have to create the network first. So docker create network rainbow. What did I do here? Docker network create would be better. Yeah. Okay. Now docker run --net rainbow --net alias es, like my Elasticsearch of earlier, -d Elasticsearch :2. So now I have 2 networks. I have the rainbow network and the unicorn network, and they both have an Elasticsearch container that has the name es. And now if I take, let's see, I want an image that has curl baked in. I think the CentOS image is great for that. I'm going to do docker run CentOS curl just to verify that. Yes, perfect. So docker run -ti -net unicorn CentOS ping es. So if I'm on the unicorn network and I try to ping es, it's pinging 172.1.9.0.2. Now if I do the same thing but on the rainbow network, CentOS ping es, then it's pinging a different IP address. And so obviously if instead of ping now I'm using curl es:9200, in that case I get like specific name and cluster ID, etc. And if I do that in the other network, then I see that I get a different Elasticsearch instance. That one is named Lightning Rod, cluster ID like 770R9 YYG. The other one was Macquarie, and the cluster ID was completely different. So that way I can bring up multiple instances of a stack, and on each instance will have its own data store, its own database, etc., etc. So if I do some, let's say, either Git bisect or A/B testing or regression testing, I can spin up multiple copies of my app, each copy completely independent on its own network, and I can figure out what behaves differently between them. Or even a simpler example, if I have two applications and both applications connect to DB, then they don't have to connect to the same database. They just connect each to a container named DB, but which is scoped by network. Okay, that's pretty much what I did. Great, alias container. And then a few caveats. This only works on networks that you explicitly define. So if you use that on like the default bridge network, so just Docker run, then you don't get names. That's just for backwards compatibility reasons, because at first in the default network there was no network aliases, etc. So we say, okay, network aliases are only for explicit networks. Okay. Oh, and last funny thing is that if you want, you can have multiple containers with the same alias. That's perfectly fine. And then on the DNS level, when you resolve that name, you get multiple records with all these containers. So you can do your own round robin or load balancing on the client side if you want. Okay. That's okay. That's okay too. And this is addressing a question that was asked, like, is this on a single machine or multiple machines? If you enable swarm mode, then all these things become available on multiple machines as well. Okay.